Hello, dear friends. It's a beautiful day today, and I'm away from home, collecting stones containing precious metals. I've collected about 500 to 600 kilograms of various ores, full car. In this video, I'll only process a third of the stone I brought in. Right now, I'm just crushing the ore. Due to the high mineralization, the stone samples literally crumble. Examine the ore carefully. It contains a lot of iron and lead, and some samples even show traces of copper. Gold content can range from 1 gram per 100 kilograms of stone or more. This ore also contains large amounts of magnetite, which makes washing the crushed ore difficult. I pre-soaked the crushed ore with a small amount of water to prevent dust from flying around during crushing. If the ore is not wetted with water, a lot of dust is formed, which is dangerous to inhale. It may contain various harmful elements, including mercury. In an hour, I prepared and loaded 200 kilograms of crushed ore into the rod mill for regrinding. After another hour of operation, I'll open the lid and check how finely ground the contents have been. Time has passed. I want to clarify these production stages. Stones vary. Some are crushed to the desired size in an hour, while others require more time, and this ore was exactly that. If the ore contains a lot of magnetite, then crushing it takes longer, as such a rock is very heavy. At the initial stage, it crushes easily, but the particles themselves are dense and hard. I opened this hatch and I see that more water needs to be added, and I have already checked that the grinding is insufficient. Now I will additionally grind this substance for 1 hour, until maximum abrasion. At first glance, everything is fine, but I feel fine sand. It's better to spend time and grind extra. Additional time has passed, and now it is necessary to extract all the contents and rinse them in a centrifuge designed to extract and concentrate the heavy fraction containing precious metals. I designed and made a specially removable drum to extract 100% of everything that was crushed inside. And if you unload through the hatch, then there is a high probability that large gold particles will remain in the drum between the rods and at the very bottom. And it's very inconvenient to flush from below. There will be a lot of dirt around. In my case, the hatch is designed only for loading material. I poured half of the volume into a basin, about 100 kilograms. Centrifugal enrichment is one of the best ways to concentrate precious metals. But for it to work, many device parameters must be considered, otherwise, the results may not be optimal. 15 minutes passed, I rinsed half the volume, turned off the miracle device, and now I have the concentrate you see. It contains varying amounts of gold, 15% visible and 70 to 85% dust, the difference depends solely on the ore. A mesh is specially installed to prevent large particles from getting inside and trapping debris. Now what I need to do is collect a sample. I take a small amount of concentrate and wash it with a prospector's pan. I always do this to understand how much coarse gold was concentrated and what decisions I'll make next. Results can vary. Sometimes there's a lot of coarse gold, and we'll see how much now. At this stage, the key is to take your time. You need to work the pan carefully to avoid washing away the gold. In the future, I plan to build another centrifugal concentrator to wash the concentrates obtained after the first centrifuge. The new concentrator will be several times smaller, but its parameters will be slightly superior to this unit. Here, after washing, I get 3 kilograms of concentrate, which is still a lot of excess. My goal is to build a new device with smaller parameters and, after the second wash of the concentrate, obtain 100 grams of super concentrate. Think about it, 100 grams can easily be placed in a flask, dissolved with chemicals, or immediately melted with lead and used for cupellation. It will be much better visible this way. Look at the result, there is a lot of some kind of silver metal. Perhaps it's the lead mineral, galena that's glittering, as well as a lot of magnetite and fine gold mixed in. It is also considered large gold in mining, the rest is invisible. And it's just that the iron from the crusher is concentrated in the slurry, it's constant. Dear viewers, that's how the rubber gasket from the lid was torn with metal rods, only the rim along the edge remained. I expected to use this crusher as a ball crusher, but the results showed that metal rods can be used. The contents are removed very easily, the lid is closed, new material is loaded through the hatch and turned back on for grinding. But this is what the mill looks like inside. The rods weigh 30 kilograms each. Now I use only 4 pieces, in the future I will add a few more. A little more time has passed, I have transferred the first concentrate that I showed here, and I have already washed the second batch and I want to show you the result, the sample. This time there is a little more gold. Now I will need to wash both concentrates with a prospecting tray, and then I will do chemical cleaning. In order not to waste time with this tray, as I have already said, it will be necessary to make a new centrifugal concentrator. There will probably be a video like this. I pour the washed concentrate into a flask. It contains visible gold. Here, I carefully pour off the water. The remaining dusty gold remains untouched in the basin. It must be extracted by flotation. The next day, I start chemistry. I'll use the simplest dissolution method: salt, sodium chloride, and nitric acid. This is the cheapest way to dissolve gold and concentrate in small volumes. Dissolving all the concentrate after centrifugation is no longer cost-effective and pointless. I also test other ores for precious metal content in small flasks, but that's not relevant to this topic. As soon as I add nitric acid, a reaction begins immediately, as can be seen by the characteristic brown vapors. Nitric acid oxidizes sodium chloride, releasing chlorine gas, which dissolves the gold. A large amount of chlorine is released, so all work must be done under a fume hood or in an open area. The concentrate dissolved in a flask for 2 hours. Now that the solution has cooled, I'll filter it through regular newspaper. The color is a pleasant, light green, indicating the presence of gold and copper, and of course, silver somewhere in there. I've already used this filter several times to purify other solutions. Regular newspaper has proven to be the best filter paper. It can withstand even hot acidic solutions without tearing easily. Several days passed, and during this time, I obtained this clear solution, which I'll now pour into a chemistry beaker. To extract pure gold, I'll use stannous chloride and hydrazine hydrate. For example, sulfide reagents shouldn't be used in the initial step, otherwise, along with the gold, various turbidities and dirt will separate. I first add stannous chloride to the solution, which separates the gold, and since the solution contains nitric acid and sodium chloride, to prevent the gold from redissolving, I add hydrazine hydrate to stabilize the solution. You can first evaporate the solutions or use various chemicals to neutralize the nitric acid, but my simple method is cost-effective and time-efficient. It's also important to remember that while I was filtering the solution, I added 15 to 20 times the volume of water equal to the acid, making the solution incapable of dissolving pure gold. And now the most precious thing, hidden beneath this rusty mud. I check the degree of grinding using a simple method, and I feel the material is suitable for flotation. There are no sand grains, the pulp is elastic like cream or cement dust, meaning it's ready for further processing. First, the pulp needs to be stabilized, otherwise the gold won't be extracted. To do this, I add special chemicals, additives, to the concentrate. Now everything needs to be thoroughly mixed, the added chemicals prevent the particles from clumping and keep them suspended. I stirred this rusty pulp for about 5 minutes and then let it sit for a few more minutes for the best results. This simple detergent, when mixed, forms fine bubbles, which increases the percentage of precious metals recovered after the final flotation stage. This yellow canister contains the liquid I'll be using to extract precious metals. I'll be using oil flotation, and the diesel fuel in this canister is perfect for this. Diesel fuel is quite fluid, wets metal particles well, and thus captures them, floating them to the surface to form a precious foam. For example, using motor oil or any other oil for flotation won't work, as the oil's density is too high to easily and freely wet non-ferrous metal particles the way diesel fuel or gasoline does. I pour several liters of diesel fuel into a bowl and mix everything thoroughly. I immediately observe how the diesel fuel already captures some minerals, primarily sulfide minerals, forming a foam. I've mixed everything and need to add more diesel fuel to the pulp. This time, for some reason, it's using twice as much diesel fuel as usual, and I can see that not enough has been added. After all this, all that's left to do is fill the tank with water. The excess will settle to the bottom, and a flotation froth containing non-ferrous metals and sulfide minerals will form on top. This is what the foam looks like up close. It seems like a lot of it. That's because right now it's airy, like porous chocolate, but after filtration and roasting, 50 to 100 grams of rich concentrate will remain. Meanwhile, the gold sediment in the chemistry beaker has already begun to coagulate. An hour has passed, and now I'll remove the flotation foam. This can be done with a regular ladle. This foam can contain between 1 and 10% gold, and the maximum recovery from the pulp this way reaches 98 to 99%. My friends, if after watching this video you're tempted to extract gold with diesel fuel, I want to tell you that you won't be 100% successful. You'll likely make many mistakes, such as, the material won't be sufficiently crushed. For a positive result, you'll need a centrifuge to remove the excess fraction. You'll also need various chemicals to stabilize the pulp for flotation. If you simply pour diesel fuel into the charge, then, most likely, only sulfide minerals that may contain gold will be obtained. Diesel fuel flotation wasn't invented by me. This method was used in the early days of metallurgy, as the first attempt at using flotation to extract ferrous and non-ferrous metals. Now I will simply filter it through newspaper. This way I will get rid of water and diesel fuel, 90% of which is returned for the next flotation. The next morning, the gold precipitate had settled in flakes, with some clumps floating in the solution like seaweed. Now I'll filter the solution to obtain the washed gold precipitate. As you can see, the gold is light brown, which is good. The precipitate was removed from the solution clean. This is why I always use stannous chloride and hydrazine hydrate for recovery, otherwise, the result can be very dirty. Yesterday, I filtered the gold precipitate, poured it all into a beaker, and added a little alcohol to neutralize any remaining nitric acid. Now I want to clean the gold precipitate with sulfuric acid, boiling the precipitate. A slight white cloud formed overnight, most likely lead. It took 30 minutes, but I'm satisfied with the result. I obtained a clear solution. This precipitate can be filtered through paper and then melted. The white cloud has dissolved, and I've noticed the precipitate has become lighter. I will melt the precipitate with gold in a muffle furnace, and for the place of the crucible I will use such a ceramic lid from some kind of dishes. I carefully put it in the muffle furnace and then add a little borax, and turn on the heat for 20 minutes. After 20 minutes, the muffle furnace was heated to a temperature of 600 to 800 degrees. Now you can fuse the filtered precipitate together with the filter, the paper will burn, and the gold will fuse into an ingot. At this point, a small problem occurred. During the folding of the filter, it began to crumble. This is due to the effect of sulfuric acid on the paper after filtration. But I noticed it in time and just wrapped everything in another piece of paper and didn't spill anything. After another 20 minutes, the muffle furnace reached the desired temperature, and the gold precipitate melted neatly into a ball. After a few minutes, I reduced the heat to let the gold cool slightly, and the ingot easily emerged from the glassy borax. In my opinion, everything worked perfectly, the crucible didn't crack. This means I'll be melting gold in it regularly from now on, and I got it for free. The gold ingot is clean and yellow. Now I'll boil it in dilute nitric acid for about 10 minutes to ensure its purity, and then weigh it. That's how much coarse gold fraction I managed to extract from 200 kilograms of ore. I consider it a good result. And it's important to understand that this was done using a centrifugal concentrator. In any other case, the result would have been 10 times smaller. Meanwhile, the flotation sediment is successfully filtered through newspaper, gradually compacting and shrinking in volume. The rich sediment, containing sulfide minerals and base metals, remains on the filter. I also noticed that if I look closely on a clear day in the sun, gold particles shimmer in the sediment. Some dust particles are barely visible to the naked eye, but a video camera won't capture them. Three days have passed since I began filtering the flotation concentrate. During this time, I have completely filtered the entire volume. Water and diesel fuel have seeped through the paper, leaving only a rich sediment. Now I need to transfer all the sediment to this stainless steel calcination bowl to remove any remaining diesel fuel. As you can see, after filtration, the sediment has compacted, and there is much less of it than initially. This sediment is virtually free of quartz particles and rock dust. The concentrate consists of various metals. Precious metals can contain from 5 to 25%, sulfide minerals from 60 to 80%, and iron dust from the crusher from 1 to 2%. Another 90% of the diesel fuel is returned for further flotation and can be drained into a canister for storage. I will burn it in the sauna stove. I don't have another stove. You can even just use a fire. You don't need a lot of fire for this. Diesel fuel burns well, and in 20 minutes everything will be finished. This is the result I got, a fired material ready for further work. Now, to obtain gold, I'll use a simple cupellation method. I take this fired concentrate and pour it into a bag for mixing with fluxes. I'm weighing a piece of lead that I'm about to add to the crucible. I'm curious what its weight will be after melting. It's time to add and mix the simple alkaline substances. First, I add sodium hydroxide, caustic soda, but be careful not to overdo it. Otherwise, the material will foam during heating. The second substance I add is sodium bicarbonate, baking soda, several times more than the first component. And finally, I add sodium tetraborate, borax. Using these three components, it's easy to fuse the flotation concentrate with the lead. Melting requires crucibles that are resistant to aggressive environments. I use homemade ceramic ones, which are enough to melt various materials 8 to 10 times. I will not fully load the crucible to the top, otherwise, during heating, the drill expands and increases in volume like popcorn, but we have a different movie here. I do not need to lose such precious material. I'll add the rest as soon as the first portion melts. Now I turn on the muffle furnace. As you can see, the furnace is already in poor condition and needs to be repaired. The door has almost fallen off. There have been emergencies inside the furnace more than once, when crucibles burst, metal spilled, heating coils burned out, and the thermocouple has long since crumbled. Nevertheless, the muffle furnace is still working, and I am loading the crucible into it. I'll fix it soon. It'll be almost as good as new. I warm up at 800 to 900 degrees, which is enough to fuse gold and lead and achieve a 100 result. Overheating above 1000 degrees is not worth doing. It will not increase the volume of gold, and that the crucible may burst, most likely. The first portion warmed up and melted after 1 hour of time. 200 degrees are displayed on the muffle furnace controller, but in fact it is already 800 degrees. This is because there is no thermocouple in the furnace. I just twisted the wire for the place of the thermocouple, and this causes incorrect readings that only I understand. The moment came to add the rest of the concentrate. Everything melted perfectly. The crucible did not burst. More time has passed, and I'm heating up the cone mold into which I'll now pour the contents of the crucible. Everything has fused perfectly, and we'll find out the result soon. It's also important to take precautions, protecting your face from splashes. The contents have cooled down and can be removed by hitting the concrete floor or using a hammer. Everything turned out perfectly. Slag is like glass. This is a sign of high-quality melting. This slag does not need to be thrown away. It can be used 2 to 3 more times to melt the next batches. I will put it away for storage. In my opinion, everything looks great. Everything is most valuable in this piece of lead. Now I'll make a simple font out of cement and plaster. I'll simply mix these two free-flowing mixtures half and half and tamp the mixture with my hands in a ceramic cup, creating a sort of crucible. Plaster and cement absorb lead vapor well, leaving only the precious metal. To begin with, I warm up the font to 800 degrees and check whether cracks have formed or not. If cracks appear, they can be fixed with a simple mortar while the font is heated, and only after that you can put workbly alloy in it. The muffle furnace has warmed up. Now you can put a font in it. The whole procedure will take 1.5 to 2 hours, and as a result, gold will remain in the composition, which will be copper and silver. The process has begun, and I will be watching it every 20 minutes to show you the last stage of the cupellation. And after 1 hour of time, the cupellation is approaching the finish line. Note how lead stains flow on the surface of the alloy. These are signs of the presence of precious metals, and the lead evaporates. After 20 minutes, the process was completed, all the lead evaporated, and now I take out the font, and the gold remains fused into a ball. Its purity is not the highest grade. In my case it almost always turns out to be 800 to 850 samples, in this range. While the font is hot, I try to take out a piece of gold in time, otherwise it will be more difficult to do it after cooling. Finally, I boil the resulting gold ingot in nitric acid to get rid of the remaining lead oxide. In the end, this is what I got. I consider it a good result, considering how much work it took to detect this precious metal. 4.18 grams of 800-grade gold dust was contained in the concentrate after enrichment. I also obtained 1.9 grams of pure gold using a prospecting pan and chemicals. Now you can compare the results. This type of gold is usually elusive using simple means, and chemicals aren't 100% effective at extracting it. Using flotation, I spent pennies on diesel fuel and a little lead, but using chemicals, the same procedure would have been expensive, time-consuming, and resulted in significant losses of precious metal. We got 5.24 grams of gold from 200 kilograms of ore. This is where this video ends. Bye everyone and see you soon.